Good day, class. So our topic is about polynomials. So what do we mean when we say polynomial? A polynomial is a special kind of an algebraic expression where each term is a constant, a variable, or a product of constants and variables raised to a whole number exponent. So we have here examples of polynomials. First is 15x. So as you can see here, it's a combination or a product of constant and a variable. And the exponent of the variable here is 1. Therefore, it's a polynomial. Second, we have 5x squared plus 15x plus 2. So the first two terms here, 5x squared and 15x, are both product of constants and variables, and the last term is a constant. Therefore, it's a polynomial. We have here the third, a plus b all over 3. So here, the numerator are both variable, separated by addition. So we have a and b. And then the denominator is a constant. Still, it's considered as polynomial. So how do we know if it is not a polynomial? So we have three conditions. It is not polynomial if the variable is in the denominator. Second, when the exponent of the variable is not a whole number, meaning to say it's a negative number, right? Third, when the variable is under a radical sign, or what we call the square root. So we have here examples of not polynomials. So if we try to observe the first example, 2a plus b all over 3c, it violates our polynomial or our definition of a polynomial. And as you can see here, it condones to our first condition of not being a polynomial, which the variable is in the denominator. As for the second, if we observe each of the terms 5x squared plus x raised to negative 3 plus 2, here on the second term, okay, the exponent of the variable is a negative, which is not a whole number. Therefore, it's also not a polynomial. Take note that we have to look at the exponent of the variable. Okay, it should not be a whole number for it to become not a polynomial. And lastly, letter C, we have the square root of x. Okay, so as for our third condition, the variable is under a radical sign or symbol. Therefore, it's not a polynomial. Okay, but if these three conditions are not seen in the given, therefore, it's a polynomial. So since we discussed what polynomials and algebraic expressions are, let us observe or let us review what is meant by term. So a term is an element of a polynomial, which is a constant, a variable, or a product of constant and variables separated by plus or minus signs. So this time, it's a polynomial still because it's a constant, a variable, or a product of two, but this time it should be separated by plus or minus signs. Example, we have here 3x cubed minus 15x squared minus 3. Our first term is a product of a constant and a variable. Okay. Second term is 15x squared, same, a product of 2. And the last term is constant, meaning to say each of these are called terms. And in this given expression, we have three terms. First, second, third. And they are separated by minus signs. It's either plus or minus, but in this given example, they are separated by minus signs. So that is the meaning of term. Let's now define what coefficient means. So, coefficient is popularly known as the numerical factor of a term. Okay, in the next video, we will define or we will differentiate the two kinds of coefficient. But the term itself, coefficient, it means that it's the numerical factor of a term. Example, we given example earlier, 3x squared plus 2x minus 1. So in this given, the terms are 3x squared, 2x, and negative 1. So the coefficient here are the numerical factors. In the first term, the numerical factor or the coefficient is 3. And this one is the variable part. So the second term, the coefficient is 2. Okay, and the last term, the coefficient is of course negative 1. That's the numerical factor. So how do we classify polynomials? So we classify polynomials according to its number of terms. Okay, so if we have only one term, we call that as monomial. An example of which is 3x. Okay, only one term, monomial. Second, if we have two terms, it's called binomial by the term bi. An example is 3x plus 3. As you can see, we have two terms separated by plus sign. For three terms, we have trinomial. An example is x squared minus 3x plus 3. So we just need to count the number of terms. And lastly, if it's more than 4 or more terms, this is what we call now the multinomial. And this is an example of that. X cubed minus 2x squared minus 3x plus 3. Okay, so it's very easy to remember these because the prefix, okay, mono means 1, bi means 2, tri means 3, and multi means more than 3. Okay. So now let's proceed to the degree of a term and the polynomial. Let's discuss first degree of a term, meaning to say just one term. So this is the sum of the powers of each variable in a term, or the sum of the exponents of the variables. Okay, examples. We have here 8. We all know that 8 is a constant, and as you can see, there is no variable. Therefore, the degree is 0. Okay. Second example, we have 5x. Looking at the variable, the exponent of x is 1. Okay, there's always an invisible 1 here. Therefore, it has a degree of 1. Next, we have 7xy. So we have here two variables and their exponents are both 1. Okay, since it's the sum, we have to add the exponents. So 1 plus 1, the degree is 2. Okay, and lastly, we have 7ab squared. Here, we have again two variables and the first variable a has an exponent of 1. As for b, we have square or exponent of 2. So getting its sum, 1 plus 2, the degree is 3. Okay, so that's how we get the degree of a term, one term. How about the degree of a polynomial? Meaning to say we have two or more terms. So how do we get its degree? So here, we just need to get the highest degree for a term. Meaning to say we have to differentiate or to classify which term has the highest degree. Okay, examples. We have here the given 2x squared plus x minus 2 has a degree of 2. Why? If we try to look at the first term, we have here the given 2x squared. And the degree of this first term is 2 because that is the exponent, right? So second term, on our second term, we have x and the exponent of that is 1. And on the last term, it's constant. There's no variable, therefore the degree is 0. So the highest degree, 2, 1, 0, of course, it should be 2. Okay? Another, we have here 3x cubed minus 4xy. Here, we just need to compare two terms. And on the first term, the degree is 3 because the exponent of the variable is 3. On the second term, we have 4xy. We have two variables. And the exponent of x is 1. Same way with y, which is 1. And getting its sum, the degree of the term here, get the sum of x and y, the exponent of them, and it would be 2. So 3 and 2. So which is higher? Of course, it is 3. Therefore, we have a degree of 3. Okay. Last example, we have 7ab squared plus 5abc. So here, if we notice the first given, we have the degree of a term 3 because a has a variable or an exponent of 1 plus 2 for b, so the degree of this first term is 3. Same way with the second term, they all have exponents of 1. So 1 plus 1 plus 1, it's also 3. So if it's the same, balance, or equal, so we need to say that is the degree, which is 3. Alright? So for your assignment, kindly do what is asked. Okay, follow instruction, and once you're done, upload your work on the LMS. Please do not forget. So here is the first one. Identify which are polynomial or not. So kindly write polynomial if it is and not if it's not. If polynomial, you have to write the degree of the term. Okay, you have to write the degree of the term. Second, we have here another 5 items. You have to write the classification of these polynomials, either it's monomial, binomial, trinomial, or multinomial, and the degree of the polynomial. Okay, so thank you for listening.